Hey, if you hear maybe God have give you wisdom, maybe from your family, from your friends, or maybe any outsider. Today we're gonna talk about LED, which stands for light emitting diode. Here is common LED, which is red, yellow and green, and another one which is white LED too. Each LED has its own characteristics for voltage but same in current. For yellow LED, it has estimated voltage drop of 1.8 volt. For red LED, it has estimated voltage drop of 2.1 volt. For green LED, it has estimated voltage drop as same as 2.1 volt. For white LED, it has estimated voltage drop of 3.5 volt. All the LED has its own desired current, which was around 25 to 30 milliampere. Besides LED, electronic equipment and component that we need is multimeter, as it functions to measure voltage and current for the LED. As well as we should prepare the breadboard for component to place on it. Some DuPont wire. Various resistors for limit the current and voltage. And last but not least, any DC such as battery act as power source. A simple formula that can use for figure out which is Ohm's law. The formula of Ohm's law, which is V equals to IR. V stands for voltage, I stands for current, R stands for resistance. To get the V in our formula, we need to know two things, which is voltage of our power source and the voltage of our LED, which is known as forward voltage or voltage drop in the circuit. And we're ready to go. Now let's start by powering LED on series circuit. And yet before we go, three expressions for electric power are listed together as here for convenience. Firstly, P equals to IV. Second, P equals to V square over R. And thirdly is P equal I square R. Okay, this is our schematic diagram, which is basic for our LED to be connected in series. So right here we got LED, resistor connected in series, and battery. So for the symbol, you know that symbol, this is resistor symbol. And for LED is this. This is LED. So we got 9 volt battery here, and our LED, which is yellow color, will be have 1.8 voltage drop, or is voltage drop in the circuit, or known as forward voltage. Forward voltage. So right now we need to find what's the resistor here. So we stated that 9 volt minus 1.8 voltage from the yellow LED forward voltage. Then we will get, so 9 minus 1.8 equals to 7.2 volt. So it's 7.2 volt. So we know there is 7.2 volt left in the circuit. By using Ohm's law, V equals to IR. So we know the voltage is 7.2. Current, we know that is standard 25 milliampere. So you have to find the resistor. So resistor is equals to 7.2 divide 25 milliampere. Okay, now we're done with it. Let's go to the bench and build the circuit. To determine the LED positive and negative terminal, the longer leg is positive, which is anode, and the shorter leg is negative, which is cathode. And another indicator is, normally you see the flex side, which is inside the LED, is negative, and the straight here, this side is positive. This is the flex side, you can see inside the LED. First of all, we verify the LED and resistor using multimeter. To check the continuity of LED, simply switch on to continuity mode. If the LED light up, means it function. To check the resistor of resistance, simply switch to resistance mode. In this case, we are using 278 ohm, which is near to 288 ohm. First of all, let's start with hooking the pin wire into the breadboard. Okay, this to the positive rail here. Next is we go to resistor. So let me get straight a bit. Yeah, there you go. Then next is LED. So you can see here, right, just now which we talked about, the flex side is negative and the positive side is the straight one. So let's hook it up into the breadboard. Right, there you go. So the next is put the dew point wire, set it up here, right, to the negative terminal. Okay, last but not least, we hook up the battery, which is power source, to the positive terminal. Oops, there you go. The negative terminal, there you go. And set to the true, which is the best significant, which is here. The best significant for check the voltage. Okay, now it's set to the voltage. Using multimeter. So it's around 2.1 volt. Yeah, it's indicate 2.1 volt. You know why it's 2.1 volt? What happening is the LEDs have to work hard because we're hooking up less value resistor into the breadboard. Alright then, let's do another series circuit. Here's another example where LED is connected in series with the resistor. This time we're hooking up red LED to the circuit, which means this all is got red LED. In this case, we know that battery is 9 volt. We don't know the resistor. So the LED is red, which is estimate voltage drop of 2.1 volt. Okay, 2.1. Voltage for okay. So you know that 9 volt, the circuit, the whole circuit, minus 3 times, which is 3 LED times 2.1 volt, equals, so 9 minus 2 times 3 times 2.1 volt. So we got 2.7 volt. 2.7 volt. So 2.7 volt left running in the circuit. By using the formula Ohm's law, V equals to IR. I 25 milliampere. R we don't know, and voltage is drop. Voltage left in the circuit is 2.7. So by using Ohm's law, V equals to IR, voltage left in the circuit is 2.7. So let's calculate the resistor. .7 divide 25 milliampere. So we got 108 ohm. So that's done with it. Let's go to the bench and we create another circuit. It's better if you organize like this because it's easier when you want to find which resistor you want. Alright, welcome to the bench here. So we hook up the resistor first. Yeah, okay. Then we'll light up. So next is LED. Positive, negative. The long one positive, shorter one is negative. So we put it here. So the next, another one. Okay. Then another one. Connected, and last but not least is the put the DuPont wire here to the negative terminal. Okay, let's light these things up. Here, battery to the positive and another one to the negative terminal. There you go. So it light up in series. So what we need to do is we need to measure the voltage drop to verify is it 2.1 volt on the red LED. So go to the multimeter. To here. Set to the DC 200 volt. Here. So the voltage drop is around 2 volt. Yeah, it's almost 2.1 volt. So I think it's a good result. Hi, welcome back. So we're gonna talk about now is powering LED in parallel circuit. So you see here the resistor and the LED is connected together here and here, which in parallel. So for the parallel circuit, the current is, we have to add up the current, and the voltage is equal, means current for the LED we have to add up here, means these two LED we have to add up the current, and voltage is the same, means we're using 2.1 volt red LED here. So the R total we don't know yet. Okay, and the battery is 9 volt. So for the current we know we have to add up both LED current. So is total current for LED. $25 milliampere for each LED times 2. We got 2 LED here, so that's equals to 25 times 2. So we got 50 milliampere. Alright, so we know the voltage drop there is 2.1 volt from the red LED. 9 volt minus 2.1 volt, so we got 6.9 volt, right? So for the voltage drop is 6.9 volt in the circuit, so we can put in the Ohm's law. V equals to IR, I which is 50 milliampere, R we don't know yet, and V is 6.9 volt, which is the voltage drop. So 6.9 volt divide 50 milliampere, 6.9 divide 50 milli, right? So we got 138 ohm. So in this case you have to hook up 100 ohm nearest, which is 100 ohm. Nearest 100 ohm. So let's get to the bench and we build a circuit. Alright, we now at the bench now. So let's start by hooking up the resistor, which is 100 ohm. Right? Let's put here. Then the next is LED. Then tube-on wire. To the negative terminal. Okay. Then other side. then LED. Okay, then we put the white ribbon. Alright, so put here to the negative terminal. Right, so we can power up now. Positive and to the negative. There you go. Parallel circuit. Okay, so now let's hook up the multimeter and we check the voltage of the LED. Okay, it didn't indicate 2 volt here. Yep, it indicate 2 volt. Almost 2.1 volt. Same as here also. Yeah, also 2 volt. That's our conclusion for parallel circuit. So that's all. Hey, welcome to bonus section. Now we're gonna go through Maker Uno X. First, open your web browser, go to www.arduino.cc. This is website for Arduino. So from here, we want to get software for our Maker Uno. Click software, then scroll download to download the Arduino IDE. I will do the window installer. If you're using Mac, then choose Mac OS X. Then for this, I'm gonna go window installer because I'm using Windows. Then press just download. After the download, then open the install the Arduino, just proceed the step. Now for the next, go to www.cytron.io. Then search Maker Uno. Here got ebook that can guide you through Maker Uno X. Download the driver, CH34X driver, then open. Make sure Maker Uno X is connected to computer USB port during installation. Then install. Now open the device manager, check the port USB serial. Which shown CH340 COM4. Then we can proceed by clicking Arduino IDE software. Now we're gonna do simple basic blink function. Choose tools, then COM4. Then we press upload. Now save as LED blink file. Alright, done uploading. So stated here which as pin mode set as 7 to output and digital write pin 7 to high mode, make it light. You can try different examples such as melody tune and much more for beginner learning purpose. Right, that's all for me now. You can get the free ebook which on the Maker Uno X. They have some tutorial can let you get going. Alright, that's all for me. Thank you very much for watching, and we see you next time. Bye.